there's a term that you mentioned as you were describing what excites you most about your work that I've got to admit I don't understand very well, and so I bet a lot of our audience doesn't as well, which is this idea of a kernel. So when you talk about an algorithm kernel, what does that mean?
Absolutely. So fundamentally, a kernel is a function that's defined by the user. And when you're thinking about programming up at the Python level, we don't really think about that way. Everything we define is user defined. So we're like, what gives? Everything I write is a user defined function. This thinking breaks down the further down the compute stack you go. So if you want to run a program on Trainium and Inferentia, for example, the way that happens is you write your program in Python, you write your program in PyTorch, and then you're going to compile that through something that's called PyTorch XLA, so Accelerated Linear Algebra. What PyTorch XLA is going to do, it's going to take the model that you defined and it's going to represent that as a graph, essentially. So the structure of your model is represented as a graph. We call that graph an HLO, high-level operations. So you get this HLO graph, and then essentially we do a handshake between that HLO graph that's generated from XLA, and we feed that into the top of our compiler. And so we maintain a compiler that takes the graph that you produced from PyTorch and from PyTorch XLA, and we convert that through a variety of algorithms and processes to ultimately generate the instruction set that actually gets executed on the hardware directly. So what's a kernel? A kernel is where you override the compiler and you get to define the operations on the chip yourself using our kernel library. And our kernel library is called NIKI, the Neuron Kernel Interface. So fundamentally, a kernel is a function that's defined by the user and not as generated through the compiler. Now, there's a huge variety of sizes of kernels, right? So you can have a kernel that's really just a hello world function, right? Where it's like, hey, I did a matmul, or I did like TensorAdd, right? And that's like to get the software working and make sure you have the environment, ready. But then what most people will do is build on top of that to define a full operation. So you'll define like a full forward pass for your model, or a full backward pass, or even just a part of it, like maybe just the MLP, up projection or down projection. And then what you're doing is you're studying the compute optimization of that kernel. Like you want to look at the data movement, you want to look at the, utilization, you want to look at your memory utilization, your compute utilization. And so I know you've had Ron on the session in the past, and so like everything Ron, teaches us and teaches the world about like compute optimization, we try to apply that when we're developing our kernels. So we study like the compute requirements of a workload and we try to improve it. Like that is the heart of writing a kernel and implementing this algorithm that you have that's trying to improve something for large language models. We implement that as a kernel in order to improve the performance for it.